Hello and welcome to a new video on cryptography for everybody in the classical ciphers series. In today's video, we will have a look at the Beaufort Cipher. A viewer of this channel asked us if CrypTool 2 is able to encrypt and decrypt using the Beaufort Cipher. And it was able to decrypt and encrypt, but not in a single component. You had to combine several components to do so. So over the last weekend, I implemented the Beaufort Cipher and the cryptanalysis in CrypTool 2. And in today's video, I will discuss the Beaufort Cipher, its cryptanalysis, and I will also show you how it works in CrypTool 2. We structured this video into 4 different parts. In the first part, we will see who Sir Francis Beaufort was. After that, we will look at the Beaufort Cipher that was invented by Francis Beaufort. After that, we will see a brief overview of the cryptanalysis of the Beaufort Cipher. And finally, we will do it in CrypTool 2, meaning we will encrypt and decrypt text using the Beaufort Cipher, and we will also have a look at the cryptanalysis of the Beaufort Cipher. Sir Francis Beaufort was an Irish hydrographer, Rear Admiral of the Royal Navy, and creator of the Beaufort Cipher and the Beaufort scale. Probably many people know the term Beaufort scale. And he lived from the 27th of May 1774 to the 17th of December 1857. And he had a quite impressive career. He began his career on a merchant ship of the British East India Company. Then he obtained his midshipman during the Napoleonic Wars. Then he became lieutenant in 1796. He became commander in 1800. And he became captain in 1810. And then later he became the official hydrographer of the Navy in 1829. And a hydrographer is responsible for the production of charts for the Navy. And he retired as Rear Admiral in 1846. And as I already said, he's known for the Beaufort scale, and that is an empirical measure that relates wind speed to observed conditions. And that is for us interesting here in that video, he's known for the Beaufort Cipher. And the Beaufort Cipher is a cipher similar to the Vigenère cipher. We already had, I think, several videos about Vigenère ciphers on this channel. And you will learn more on how it's similar to the Vigenère cipher on the next slides. And Francis Beaufort encrypted letters and journals using his invented cipher. And you can see a picture of Sir Francis Beaufort that I found on Wikipedia here on the right side. Now let's have a look at the Beaufort Cipher. And the Beaufort Cipher is a polyalphabetic cipher. That means it uses different alphabets, as you can see on the right side of the slides here. And it's quite similar to the Vigenère cipher. It uses a keyword and it uses a lookup table, but with inverse alphabets. What this means we'll see later. And here we have an example encryption. So we want to encrypt here the sentence or the words "Hello World." And to do so, we need a keyword, and our keyword is key. And when you want to encrypt using the Beaufort Cipher, as with the Vigenère cipher, you write the keyword on top of your plaintext. So P here is our plaintext, K is our key. And with the Beaufort Cipher, but also with the Vigenère cipher, you repeat the keyword until you reach the end of the text. In our case, we have key, 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 and then a K. And to encrypt the ciphertext here, you first have a look at your plaintext letter and the key letter here. You go into that table. You look on the left side here, in that column here, you search for the K, the keyword K, and then you search here in that row on the top, you search for the plaintext letter, here this H. And where these row and column met, here where the D is, that is our ciphertext. And we do this, for example, for the next letter. We have the keyword or key letter E, and we have the plaintext letter E. So we have to search for E and E. and our encryption then is A. So we write an A in our ciphertext. And we will do this finally for the last letter of our keyword key. So we have the key letter Y and the plaintext letter L. So we search for L here, then we search for Y here, and these two meet at N here. So we write in the ciphertext the N. And we go on and on and on for each of the plaintext letters to obtain our ciphertext letters. With the Vigenère, you have to reverse it for decryption, but with the Beaufort cipher, it's quite interesting because the Beaufort cipher is reciprocal. That means that encryption and decryption are the same. So you use the same method, the same table, and when an A, for instance, is encrypted to a Z, then the Z will be decrypted to an A back. And you can use the same table for that. And encryption and decryption can be described algebraically, where A is 0, B is 1, C is 2, and so on. And for encryption, we use this equation here. So our ciphertext letter at position I is our key letter at position I minus the plaintext letter at position I modulo 26. Of course, the key letter we obtain by this here, by the key that's written again and again and again above our plaintext, and our plaintext letter we obtain by having a look at the plaintext. For instance, having the I equal to 0, we get K for the key letter here, we get H for the plaintext letter here, and I have an example encryption here, so K minus H equals 10, because K is encoded with 10 and H is encoded with 7. So we compute 10 minus 7 equals 3, and the 3 is our D, as we can also see here. And the most famous application of the Beaufort cipher was in the Hagelin M209 cipher machine in the year 1936. And we already had a video of the M209 cipher machine if you're interested in details on that machine and how the Beaufort cipher was used in that machine. Now let's have a brief look at the cryptanalysis of the Beaufort cipher. And first thing that cryptanalysts do is to compute the key space size. And the key space size of the Beaufort cipher of a keyword of length n is 26 to the power of n. As I said, where n is the length of the keyword. And here on the right side, you can see the different key space sizes for the different key length. And viewers who already know the Vigenère cipher also know that this here is the exact same computation that we would have done for the Vigenère cipher. So for a key length of 1, we have 26 possible keywords, if you could say so. So A to Z is our keyword then. So we have about 2 to the power of 5 keywords. Then when we add an additional letter to our key length, to our keyword, we get 676 different keywords. And the more letters you add to the keyword, the bigger our key space size is. And we have here some quite impressive key space sizes, I think. A key length of 20 letters already has a key space size of about 2 to the power of 94. And of course, when you have a Beaufort encrypted text, you have to add all these different keyword sizes. So we have key length 1, 2, 3, and so forth. And you have to add all the different key space sizes to get the overall key space size, for instance, for keywords from 10 to 1 key length. So how can the Beaufort cipher be broken? It can be broken with the Kaczynski test that is also used for the Vigenère cipher to obtain the key length. The Kaczynski test is a test where you can compute a probable key length of Vigenère and also of the Beaufort cipher. And when you have the key length, each column based on that key length, so for the first letter, you have a column of letters. For the second key letter, you have a column, and so on. And each of these columns in the text is a simple shift cipher. And today we break Beaufort ciphers easily with the help of hill climbing. So the Kaczynski test and then this column analysis thing here was mainly for cryptanalysis by hand. And as I said, today we can easily break Vigenère but also Beaufort ciphers using hill climbing, for instance with CrypTool 2. And a Beaufort cipher can also be converted to a Vigenère cipher by replacing letters by their inverse letters. What does that mean? It means that you replace an A by a Z, a B by a Y, a C by an X, and so on and so forth. And when you do this, you can analyze the Beaufort cipher as if it is a Vigenère cipher. In fact, you just changed it to a Vigenère cipher. We will see how this works later in the CrypTool 2 part of this video. And similar to the classic Vigenère cipher, where we have a Vigenère autokey cipher, there is also a Beaufort autokey cipher, which uses plaintext as additional key material following the key. So instead of writing the keyword and then the keyword and then the keyword above the plaintext, you write at first the keyword and then you write a copy of the plaintext above the other part where there's no keyword, and this is what we call the autokey cipher. And these, of course, can also be analyzed in CrypTool 2. And over the course of the last weekend, I implemented the Beaufort and Beaufort autokey cipher and their cryptanalysis in CrypTool 2. Now that we know what a Beaufort cipher is, let's have a look at the new Beaufort cipher implementation in CrypTool 2 and of course its cryptanalysis in CrypTool 2. And you will also see how you can change a Beaufort cipher with a monoalphabetic substitution cipher into a Vigenère cipher. So let's go to CrypTool 2. I'm here now in the Start Center of CrypTool 2 and I use the nightly build 9232.1. So if you want to use the Beaufort cipher on your own, you have to update at minimum to this version. And to work with the Beaufort cipher, we can search for the Vigenère cipher since we implemented the Beaufort cipher in the Vigenère cipher component. And we have two Vigenère cipher templates here in the Start Center that you can open. And I first open the Vigenère cipher workspace here. So we have here an example text. And when we press play here, this text gets encrypted using the Vigenère cipher and it gets decrypted using the Vigenère cipher. And probably my head is in the way, so we have the key here. The key is secret key. So here is our cipher text. This is Vigenère encrypted. And of course, we can decrypt it using the Beaufort cipher. And when you go to the Vigenère component, you open the settings here. You can see we have Vigenère Classic and Vigenère Autokey. But you can now also change to Beaufort Classic and Beaufort Autokey. And we want to test Beaufort Classic. So I change this to Beaufort Classic. And of course, when I don't change the second cipher from Vigenère to Beaufort Classic, we cannot decrypt it since this is a Vigenère cipher now and this is a Beaufort. So we also have to change the second Vigenère component to a Beaufort Classic cipher. Now when we press play again, you can see we get here our cipher text and here our plain text, both encrypted and decrypted using the Beaufort cipher. This also works with Beaufort Autokey, so you could change this here to Beaufort Autokey, this here to Beaufort Autokey, and then you have a Beaufort Autokey cipher. I change this back to a standard classic Beaufort. And this is the new implementation of the Beaufort cipher. As I said, the Beaufort cipher's encryption and decryption method is the same. And since it's the same, you can just change the second component here, that's Beaufort Classic, to encrypt also. Now we have both components set to encrypt, but as you can see, since encryption and decryption is the same, also here the encryption works without any problem. And this is how you can use now the Vigenère components to encrypt and decrypt Beaufort ciphers. Now let's have a look at the cryptanalysis. For that, I copy here the cipher text. We know it's encrypted using the Beaufort cipher. Stop this workspace. Go back to the Start Center and let's open the Vigenère analysis template here. We don't need this. And here we can just paste our ciphertext. Now, this Vigenère analyzer here is still set to classic Vigenère. When I press play, it won't find any solution since, as I said, it's a Beaufort cipher here. So I'll stop this here. But we also implemented the Beaufort cipher in the analyzer. So we changed this to classic Beaufort. Let's press play here. And then we can see here very quickly that this component is now able to also analyze the Beaufort cipher. The Vigenère cipher with the reversed alphabet and slightly different equation and table. Now I said you can easily turn a Beaufort cipher into a Vigenère cipher and then also make cryptanalysis as if it is a Vigenère cipher, since then in fact it is a Vigenère cipher. So let's change this back to Vigenère cipher, classic Vigenère, and now we change our Beaufort cipher here also to a Vigenère cipher. For that we need two text inputs, 1 and 2. And these text inputs will be used for our alphabet. I want the same width and the same height. So our source alphabet will be the standard Latin alphabet. And our second alphabet will be the reversed alphabet. So I hope I didn't make any mistake. So this now should be standard Latin alphabet and the reversed alphabet. Now we need a substitution component because, as I said, you can change or turn a Beaufort cipher into a Vigenère cipher by replacing letters by their inverse. Remember that the alphabet is reversed. So all we do now is also, you could say, reverse the alphabet. So we say here encrypt. Source alphabet is the standard Latin alphabet. Destination alphabet is the reversed alphabet. Now let's test it. And I think I made a small mistake with the reversed alphabet. And since I can see this is A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Now it's correct. Now let's give it a try again. And we can see here, it should be key length 9. The Vigenère cipher is a method. Yeah, it worked. So we cryptanalyzed, and I stop this here, a Beaufort cipher with a Vigenère analysis algorithm, you could say. And we did so by changing the Beaufort cipher using the substitution component into a Vigenère cipher. The problem is right now, you can see we get a keyword here. But the keyword is still, you could say encrypted. To get the original keyword back, you have to also apply the same modification or encryption, you could say, to the keyword. So the keyword here comes out in that best key output of the Vigenère analyzer. And we can just add an additional text output. So let's give these a proper name. This is keyword. This is Latin alphabet. And this is reversed alphabet. And now when we perform the same cryptanalysis again, and we get our correct plaintext here, and when we double click here, we also forward here the plaintext to the output and the key to the output. Then the key is decrypted, you can say, using a substitution component, these two alphabets, the normal and the reversed alphabet, and we get here our key. And here you can see, since we analyzed up until key length 20, you get the secret key here. So the original key was secret key, but of course when you write the same key twice, this is also a valid keyword. But here we have to substitute it to turn it from this unreadable encrypted version of the keyword to the readable keyword version here. Yeah, and this is how you can work with Beaufort ciphers now in CrypTool 2. I think this is a useful addition, since there are also Beaufort cipher challenges probably out there that you can now solve using CrypTool 2. Yes, and this is everything I wanted to show you in this short video. I hope you liked it. If yes, please give a thumbs up. Also, if you did not yet subscribe to this channel, I would be really happy if you do so. This really helps us to grow this channel and to make CrypTool 2 more popular. Also, if you're interested in videos of this kind, then you get notified when I upload new videos. So thank you very much for watching, and see you in the next video.